Okay, men, welcome back to Notes. Today we're going to talk about section 6.3, Tests for Parallelograms. And I may repeat myself a bunch today, and you may seem like you already know this. And it's because today we're going to be looking at the converse of all the theorems that we discussed in section 6.2. So starting off, I have if a quadrilateral has each pair of opposite sides parallel, then it is a parallelogram by its definition. So when I take a look to the right here, I can see that yes, I have a quadrilateral. I have a four-sided figure. So right here, this is my four-sided figure. And if I state that opposite sides are parallel, so if I was to put in my chunky arrowheads here, letting you know that these lines right here are parallel, and if I put chunky arrowheads on the east and west side, I know that that is a parallelogram by its definition, opposite sides being parallel. So this is not the only reason for a quadrilateral to be a parallelogram, and we're going to look at several more. So the following theorems that we're going to learn are more reasons for a quadrilateral to be a parallelogram. So you're going to hear me state if blank, then parallelogram. So I'm going to draw some pictures here. We're going to take a look at these theorems in great detail, and we'll try some example problems. So give me a second. Theorem 6.9 states, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I'm no longer calling it a quadrilateral. I get to call it a specific quadrilateral, and that is a parallelogram. So marking this is where I'm going to say if you see a picture quadrilateral that has opposite sides, both pair of opposite sides being congruent, then the quadrilateral is a parallelogram. Theorem 6.10. If both pairs of opposite angles of a quadrilateral are congruent. So if I see that both pairs of opposite angles are congruent, then I no longer call that a quadrilateral. I could give that quadrilateral a more specific name, and that is a parallelogram. So if opposite angles, both pair are congruent, then parallelogram. Theorem 6.11. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here segment AC is a diagonal, segment DB is a diagonal. I see that AC is being cut in half by segment DB. I see that DB is being cut in half by segment AC. So therefore the diagonals bisect each other. So now I could say that this quadrilateral ABCD is more specifically a parallelogram. It's not necessarily a quadrilateral anymore. So if I see the following, if we have a quadrilateral and the diagonals are being bisected, then I could claim that the quadrilateral is a parallelogram. That's enough evidence to claim that the quadrilateral is a parallelogram. Okay, theorem 6.12. This is a new one. We have not seen this one before, so Mr. No is not repeating himself now. This is a brand spanking new. So it says, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So all I need is exactly one pair of sides to be congruent and parallel. So they have to have the hash marks and the chunky arrowheads on one pair of opposite sides. Then that means that we have enough information to claim that the quadrilateral is a parallelogram. So if congruent and parallel, I could claim that the quadrilateral is now a parallelogram. Okay, enough with the theorems. Let's take a look at some examples. So it says, determine whether the quadrilateral is a parallelogram. Justify your answer. So I'm looking at this quadrilateral right here. I got my nice lightsaber out, so Ian, I hope that makes you happy. When I take a look, I see this side right here, this quadrilateral is 20. I see this side is 20. I also see that this side is 35 and this side is 35. So I'm going to go on and add some markings. I know that this side and the side right here with the 20s are congruent, and I know the sides with the 35s are also congruent. So looking at here, I'm definitely going to say, yes, this is a parallelogram. And remember the notation, shorthand notation, that's parallelogram. So yes, it's a parallelogram. Why now? That's the most important part. Why is this a parallelogram? And that's because opposite sides are congruent. And remember that notation, that's the congruent notation, the congruent symbol. So yes, that quadrilateral is a parallelogram. I'm going to come over here. I'm going to look at this scaffolding kind of lift thing that we have, and it says this. It says, in the diagram, angle A is congruent to angle C. So I'm going to mark that angle A and angle C are congruent, and it tells me that angle B is congruent to angle D. So I know those two angles to be congruent, and then I'm going to say, yes, again, this is a parallelogram. Why is it a parallelogram? Because opposite angles are congruent. And more importantly, for both of the situations at hand, we have both pairs. So I have angle A and angle C being congruent, angle B and angle D being congruent, so that's both pairs. Going back over here, 35 and 35, the north and the south sides are congruent. The east and the west sides here are congruent, so both pairs of opposite sides are congruent. Lastly, looking here, I see, all right, I have a quadrilateral, but I have these red arrowheads on the north and the south, and I also see that this is 15 on both of these, so that means that these segments are congruent. They have the same length. So again, my answer is yes, this is a parallelogram. So we are 3 for 3. Why? And this is because one pair of opposite, I'm going to abbreviate that OPP, sides are congruent, and remember this notation, parallel. Okay, moving on to the multiple choice question at the bottom of our paper. It says the diagram shows a car jack used to raise a car from the ground. In the diagram, segment AD is congruent to segment BC, so I'm going to mark it. And then it tells me that AB is congruent to DC. So now I need to mark my sides for AB and DC. So now I'm going to look at my choices, and it says angle A is congruent to angle B. Well, this is not true. I know, looking at this car jack, that opposite sides, both pairs, are congruent. So this will be a parallelogram. And since A and B are consecutive, they are not congruent. They should add up to be 180. All right, looking at choice B, it says that angle A is congruent to angle C, and I see that these guys are opposite angles, and I know that's a property of a parallelogram. So I'm going to go on and circle that and move on with confidence. You could read further just to double check yourself, but it's multiple choice, so I know I found a right answer, so I would move on. But here we go. Reading choice C, is segment AB congruent to segment BC? No, not true. These are not opposite sides. So not congruent. And then reading choice D, it says the measure of angle A plus the measure of angle C equals 180. That's not true. They should be congruent because they are opposite. So that's it. Let's see some more examples, and these are all going to be algebraic based. Find the value of x and y so that the quadrilateral is a parallelogram. Notice how the definitions or the questions are changing. Yesterday we said that we have a parallelogram, find x and y. Now we're asking to find x and y that will make these opposite sides congruent. So I see right here that this is opposite sides right here for x are parallel already. So in order for them to be a parallelogram, I need to have that this side and this side right here are congruent. So I would set 4x minus 1 equal to the quantity x plus 2 times 3. Here we have to use the distributive property. So we get 4x minus 1 equals 3x plus 6. We're going to go on and add the 1 to both sides. So I get 4x equals 3x plus 7. I'm going to subtract the 3x from both sides. And when I do, we get x equals 7. Solving for y much the same way, I'm going to set 3 times the quantity y plus 1 equal to 4y minus 2. I need to distribute first, so I get 3y plus 3 equals 4y minus 2. I'm going to add the 2 to both sides, so I get 3y plus 5 equals 4y. I'm going to subtract the 3y from both sides, and we get that 5 is equal to y. So x was 7, y is 5. Next example is dealing with angle measures. So I have to take a look and see, well, what can make these angles true for a parallelogram? So I have either opposite angles are congruent, or I could show that consecutive interior angles are supplementary. And when I take a look at angle E and angle G, I notice that angle E has 3y minus 2. I see that angle G is 12x plus 7. So if I try to set these equal to each other, I'm going to have a real difficult time. I have two variables in one equation. So if I look at angle G and angle F, and I notice, they both have x's. So that's going to be a sign for me to set both of these angles equal to 180. So 4x plus 13 plus 12x plus 7 equals 180. When I do that, I get 16x plus 20 equals 180. All I did was combine my like terms, subtract the 20 from both sides. I get 16x equals 160, and divide both sides by 16. We get x equals 10. So now you have a choice. Now that you know what x is, you could plug it in, and then you could set opposite angles to be equal to each other, or you could continue on with the supplementary angles like we just did. I'm going to go on and plug it in. I know that x is 10, so if I do that, I get 4 times x, so 4 times 10 is 40. 40 plus 13 is 53 degrees. So that means y plus 10 has to be equal to 53 because opposite angles will be congruent. So that means y, when I subtract 10, y equals 43. So y is 43 and x is 10. Going on to the last example in this page, in order for this to be a parallelogram, I need to have one pair of sides that are both parallel and congruent. So that means I would need to set 4m plus 2 equal to 3m plus 8. So let's go on and solve. Subtract 2 from both sides. 4m is equal to 3m plus 6, because 8 minus 2 is 6. Now I'm going to subtract 3m from both sides, and I get that m is equal to 6. All right, the end is almost near, men. So I'm just going to summarize what we talked about. To prove that a quadrilateral is a parallelogram, I need to show that both pairs of opposite sides are parallel. That's the definition. So if you look over here, I've got what that picture would look like. Both pairs of opposite sides are parallel. That is the definition. I can show that both pairs of opposite sides are congruent. So again, here is the picture. I have both pairs of opposite sides being congruent. I need to show that both pairs of opposite angles are congruent. So if I take a look, here's a picture that shows that both pairs of opposite angles are congruent. I could show that the diagonals bisect each other. So here's a picture of what it would look like if I have a quadrilateral where the diagonals bisect each other. I could show that a pair of opposite sides is both parallel and congruent. And this bottom picture has that. So what I have on this also is that I need to show that an angle is supplementary to both of its consecutive angles. So if I do that right here, that shows me that these lines, the north and the south line, will be parallel. But if I also show that the second pair of angles are supplementary, that will prove that these lines right there are parallel. So then that leads back to I have both pair of opposite sides being parallel. So let's take a look at our first example. Is ABCD right here a parallelogram? And the answer is yes. Why? Because if I take a look, 50 and 130, they add up to be 180. So therefore, I could add the chunky arrowheads, and this guy is a parallelogram, and that's because of theorem 6.12, which is opposite side is both parallel and congruent. Looking at my next example, I have quadrilateral DEFG. Is this enough? And the answer is no. All right. I have one pair of sides being parallel. I have one pair of sides being congruent. I need both pairs of opposite sides parallel, or both pairs congruent, or one pair congruent and parallel. I don't have that here. Looking at this guy, quadrilateral HIJK, again, no. Why? Opposite sides are not congruent. So I need both pair of opposite sides to be congruent. And lastly, this is a tricky. If I look at quadrilateral LAND, I'm going to get my trusty highlighter out. If I take a look, we know that segment AL and segment ND are my opposite sides. If I was to take a look at this segment LN, and what do I see there? I see that I have alternate interior angles being congruent. So these alternate interior angles are congruent. That means AL and ND are parallel. And if I was to take a look again, I'm going to try to switch her up. So if I come over here to the red, I see that segment AN and segment LD are two lines that I'm looking at. And if I take a look at the transversal again this time, I'm going to make it in yellow. What do I see? I have a pair of alternate interior angles being congruent. So therefore, I know that AN and LD to be parallel. So yes, and that's by definition of a parallelogram. Okay, your assignment will be posted onto Schoology, and I wish you guys the best.